This video is about a digital circuit called half subtractor. Half subtractor is a combinational circuit which subtracts two 1-bit number. This is the block diagram of half subtractor where A and B, these are the two inputs to the half subtractor, and subtraction of A and B will give you the result in the form of difference, which is called as D here, and a borrow, which is called as BO, that is borrow out. A in this case is called as minuend and B is the subtrahend. In short, I have to perform binary subtraction A minus B. So two inputs would be there and two outputs would be there. Let's go through the truth table of half subtractor. The input A and B can take four possible combination of values: 0, 0, 0, 1, 1, 0 and 1, 1. 0 minus 0, the difference will be 0 and borrow will also be 0. 0 minus 1, that is smaller number minus larger number. In this case, the difference is 1 as well as borrow will also be 1. 1 minus 0, obviously difference is 1 and there will be no borrow, that is borrow is 0. And in last row, 1 minus 1 means same numbers are to be subtracted. So difference is 0 and borrow out is also 0. Let us develop the Boolean expression for difference and borrow out. There are two different ways. In first method, we will directly derive the Boolean expression, and in second method, we will take the help of K-map. So let us do by first way. Now let us first concentrate on the difference, that is D column. The D has the value twice. In this row it is having value 1, in this row it is also having the value 1. So we will mainly focus on these two rows, that is this row and this row, because we are going to write the expression, Boolean expression for difference in SOP form. We will take the sum of product terms. So there will be two product terms. So the first row, in first product term, the value of A is 0 and value of B is 1. So in SOP, 0 is considered as bar and 1 is taken as it is. So in this case, this 0 means A bar and this 1 means B. So A bar B will be the product term corresponding to this row. So A bar B. Now what about the next row? This row, A is having value 1. So it is taken as it is, that is A is taken as it is, and B has the value of 0. So 0 is taken as a bar. So B bar will be there. So two product term, first is A bar B, second is A B bar. Sum of them is taken. So A bar B plus A B bar will be the value of difference, the first output. Now what about the second output, that is borrow out? Borrow out has the output value 1 only once, and which correspond to this row, that is A is 0 and B is 1. Now similarly, we will apply the same logic. As A is 0, A is taken as A bar, the value of B is 1, so B is taken as it is. So A bar B. So only one product will be there, and A bar B is the value of borrow out. Now what about the first difference term, A bar B plus A B bar? It is also called as A XOR B, because A bar B plus A B bar is the Boolean expression for XOR of A and B. So this is one way of deriving the Boolean expression. The other way of deriving the Boolean expression is to take the help of K-map. There are two different outputs, so two K-maps would be required. First K-map will be for D, that is difference. Number of inputs are 2, so the size of K-map will be 2 raised to 2, that is 4 squares will be there. A can have a value of 0 and 1, B can have a value of 0 and 1, so these are the inputs, and outputs corresponding to these inputs would be written inside the cells. In the first case, A is 0, B is 0, so A is 0, B is 0. So this corresponds to this cell. What is the value of difference? Difference is 0, so 0 is inserted here. The next, A is 0, B is 1. A is 0, B is 1. What is the value of D? D is 1. So 1 is written here. The third case, A is 1, B is 0. A is 1, B is 0. What about the output D? It is 1. So 1 is written here. And in last case, A and B both are 1, output is 0. So when A and B both are 1, output is 0. Now we have to derive the Boolean expression. We cannot form the group of 4 ones. We cannot form the group of 2 ones also, because they are neither horizontal nor vertical. So we cannot form the pair of diagonal ones. So 2 independent ones exist. Encircle the first one. Look at the left hand side, it corresponds to A bar. Look at the top side, it corresponds to B. So it will be A bar B. The second independent one is here. Encircle it. Look at the left hand side, it corresponds to A. Look at the top, it corresponds to B bar. So A into B bar is the second product term. So difference is going to be A bar B plus AB bar, and which is nothing but the A XOR B. Now let us move to the second output, which is borrow out, that is BO. Same K-map is drawn here, and we will insert the values one by one. For A is equal to 0 and B is equal to 0, B0 is 0. So B0 is 0. A is 0, B is 1, B naught is 1. So 1 is the output. In third case, when A is 1 and B is 0, the output is 0. So the output 0 is written here. And in last case, when both A and B are 1, 1, A is 1, B is also 1. In that case, output is 0. So 0 is written here. If you carefully look at the cells, you will find 1 appearing only once. Encircle it, it is independent one. So by looking at the left hand side, you will come across A bar. To look at the column heading, it is B. So product term associated with this one is A bar B. So borrow is equal to A bar B. And in order to realize these Boolean expressions for difference as well as borrow, we will require one XOR gate, one AND gate, and one NOT gate. So this shows the diagram of full subtractor. A is fed directly to the one input of XOR, B is fed directly to the second input of XOR. Output of XOR will be A XOR B, which will indicate the difference. This A is inverted by this NOT gate, so it becomes A bar, which is the first input of AND gate. B is fed directly, which is the second input of AND gate. So A bar B will be the borrow. So half subtractor can be realized by using one XOR gate, one NOT gate, and one AND gate. Similarly, if you are being asked that use the basic gates to realize the half circuit, means don't use XOR, just use AND or NOT. In such case, we will use the basic gate. So A and B are the two lines. A is made A bar by this NOT gate. B is fed directly, so it will produce A bar B. That is the first term. Similarly, second AND gate will produce A. B is inverted here through the second NOT gate, so it is B bar. So A into B bar will be the second term, and they are OR because this plus sign indicates OR operation. So one OR gate is used, and this will give you the difference. Now what about the borrow out? It is product of A bar B. Product means we will require AND gate. So this is the AND gate, and it is the product of A bar B. So A is made A bar with the help of this NOT gate, and this A bar is fed as a first input. So first input is A bar, the second input is B, so B is taken directly from here, so second input is B, and the output will obviously be A bar